I'm here today to talk about this kind of thing. I will come back later on this one. This is a new one called Mongo. Open source hardware. I'm sure you all have these in mind, Arduino, BeagleBone, and others. And until now, it's meant for educational purposes. So it's good to play with, right? But we are the industry. And ultimately, what we want is to build products out of it. Is that possible? So we're going to see that. I need the... Oops, here it is. So first of all, what is an IoT open source hardware for the industry? So the open source hardware thing is kind of obvious. We need the design to be publicly available, right? It has to be easy to build the product by yourself. And because we are in the industry, we want to build real products out of it, including commercial ones, right? We need business-friendly open source licenses. I mean, it has to be freely available to share, copy, and modify. And as well, it has to allow you to do whatever you want with the resulting product, including doing business with it. So because we are in the IoT, we have some obvious needs, and most of the Arduino, etc. guys are matching this thing. It has to be highly expandable. Versatile connectivity is as well key. You need native connectors to expand it without needing to modify the design. And the goal for a company like Sierra Wireless and our partners like Freescale TI to come up with an open source hardware today is to encourage copies derivative and a new hardware design built on top of this open source hardware, and obviously need build developer communities. And because we are in the industry, we want to enable business models, and we want to build a business ecosystem around it. So you know these guys, right? Arduino, Raspberry Pi, BeagleBone, T-Cell, etc., etc. How open are they? I'm sure most of you guys say they are the open source guys. Are they really open source? Well, so in the first column, I put the name of all these big guys. I've added the Mongo board at the end. And the second and third column, you have what you have to have for open source hardware status. It means you need to find schematics and Gerbers online, right? And the license has to allow you to copy and modify. That's what we said. So maybe it's a surprise for some of you guys. I know that in the common sense, we think that Raspberry Pi is an open source hardware. It is not. It's not because it's a proprietary license. You are not free to copy and modify, right? So you cannot use it for your own product unless you have a contract with the Raspberry Pi Foundation. On the second line, embed hardware dev kits. So it's just like all dev kits, including Sierra Wireless dev kits, the same thing. If you take a dev kit from a company, most likely you're going to have a proprietary license, right? The dev kit is not meant to be reused as a design for new products. From Arduino until the end, all these guys are real open source hardware. Real open source hardware. Just a word on open because there is no Gerbers online. It's still an open source. You have the schematics. Well, it's a bit harder. You need to hire a hardware designer, but you can still do it. Right. So we are in the industry, and we said that we want a business-friendly license. That's very important. So that's the fourth column here. The two first, no surprise, they are proprietary. There is nothing we can do there. From Arduino to T-Cell, these guys have a Creative Commons share-alike license. This license forces you to use the same license for the resulting product. It's a viral license. It means your product's going to be open source as well. So that may be fine, depending on your business model. It's going to be fine for you if you're happy with open source hardware stuff. The two last, OpenPicus and Mongo, use a Creative Commons attribution license, and the only constraint you have out of it is to get credit to the open source. So let's say in the documentation, you have to give credit to this open source project. That's it. So that's here, really, you can do whatever you want with your end product. Just a word on the fifth column, open processor and drivers. Most of open source hardware are meant to use a proprietary, a single application processor or a microcontroller, etc. That's fine. The OpenPicus and Mongo, that's interesting to note it. They come with an abstraction of the application processor. It means you can come with your own if you want. So OpenPicus does it through a FlyPort interface, which is a daughter board, a small daughter board for the board. Mongo does it through a CF3 socket. So I will show you just after. You have a CF3 socket, and you come with your own application processor with this socket and put it on board. All right. So what are the requirements for such open source hardware for the industry? So like all open source hardware, the first requirement is obvious. It has to be easy to prototype with, right? So I'm gonna go fast here. It has to be easy to use. The out-of-box experience. You have to have tons of code samples. It has to be highly expandable. So just like the Arduino, it has to accept multiple sensors, networks, and so on. Extension boards. And why not? And that's the case for Mongo here. So that's Mongo you have on the right side. You can it can fit industrial boxes just like this. And why not be compatible? I mean, if you provide online design files, you can 3D print, for instance, the faceplates for the Mongo. We'll come back on it later if you want, or after this talk. The high flexibility, that's what we said previously with the OpenPicus and Mongo. Maybe it's better if you can choose your application processor and your tooling and the language you want to work with. Now, okay, let's talk about the industry requirements. You had fun with your prototype. That's fine. Now you need to build a real product. And if you do that out of an Arduino, out of such hardware, I'm not talking about the issue with the licenses. You will have to rebuild everything, to redesign everything. That's the way it works today. This new kind of open hardware, they are meant to ease the productization. They are meant to ease you, so to avoid you to redesign everything. So, for instance, the Mongo board is an industrial standard casing. This is an Eurocard casing. You can find many boxes out there. That's easy to get. Oh. Okay. You need to have industrial-grade connectors. That's really key. And so we'll talk about that later for Mongo. You need to have industrial-grade onboard components. And you need to have a modular design that allows you to remove unwanted features, because from the prototyping, I mean, from your dev kit, or if you take Mongo as a dev kit, to your product, you will want to remove unwanted features. And it has to be easy to do on board, and you don't want to redesign everything to do that. So that's a view on the industrial-grade connectors on Mongo. With a special locking system, you can slide them, so it accepts a hot plugin. Let's say you have a box at home and you want hot plug a Wi-Fi connector or a Zigbee connector or whatever solution you want to use, including the one we talked about just before, the presentation before. So that's easy to do. Or your product has fixed connectors, and these ones you can screw them. So it's not removable. And that's a key as well. That's the ecosystem around the open source project to support you. You need technology providers to provide the sensors, new networks, et cetera, and they have to come with code samples and tutorials. That's obvious. You need distributors because you want to buy this open source hardware online, including the accessories, and of course they will be able to provide you with the tutorials and code samples. You need a system integrators to support developers and industrial projects. And obviously, you need the developer community to develop applications and share the code samples, the application, and support other people on the forum. So that's basically what we need. That's my last slide. So a word on Project Mongo. Mongo is this open source hardware for IoT for industrial needs, announced by Sierra Wireless and partners. You have all the names here. So we are missing a few names there that have been added last week. So it has been announced during the Innovation Summit in Paris in June, last June. The current phase is we are setting up the manufacturing and the distribution with partners like Element 14. And we estimate you're going to be able to to buy this online by end November. If you are interested to get notified when this project will be out, or if you just want to join the project, you can go to mongo.io right now. It has been released this weekend. You will find a lot of information, and you can subscribe to get notified and get in touch with me. Thanks.
Thibault, thank you. I understand that you launched this in beta in June. Has the response been the same as you expected, or better, or how's it been?
It's way better, actually. Actually, we receive a lot of technology provider willing to come up with an IoT connector for this Mongo board.
Yeah.
So we are currently gathering all these guys around the table. And because all of them, they need help to get it manufactured, distributed, and so on. So we help each other around the table. And yeah, so it's a lot of work, but yeah.
How often are you able to meet?
How often we are able to meet. So it's a lot of distant, we travel a bit. Fortunately, Sierra Wireless so we are a company based in Vancouver first, and then in France. So we have a team, overseas. So depending on the partner, we manage to meet the guys, North American guys and European guys. But yeah.
Well, I wish you success. I hope you'll be able to come back and tell us how it goes next year.
Thank you very much. Thanks.
Thank you.